It is. We'll see if it works, but it is. All right, here's learning target number 4 for Unit 1. Be able to solve a linear equation with multiple steps. And then I wrote down some procedures here in the blue. We need to simplify each side of the equation as much as possible. That's one of the reasons the first 3 learning targets came earlier than this learning target, is because we use our order of operations, we use the distributive property, we use combining like terms. All of that stuff might come up when we say simplify each side of the equation as much as possible. But that's what you do. Before you start trying to get x on one side or the other, simplify each side of the equation as much as possible. Once you've done that, then you do want your variable term on one side only. So get all the terms that contain the variable on one side of the equation, and then get all of the constant terms. Those are the numbers that don't have variables. Those are called constants. Get all of the constant terms on the other. And that's usually done by adding or subtracting, usually. Then you might need to simplify again. Well, you will need to simplify. Most of the time we'll do the simplifying during the same step as we do the getting them where they're supposed to be, but we don't have to. And the last, then you get the variable by itself by multiplying or dividing both sides by the coefficient of the variable. So, as you know, once you're down to x equals or something equals x, that's when you're done. Okay? All right, so we're going to go through a bunch of examples. So let's write these down. To solve an equation that has variables on each side, use the addition or subtraction property to write an equivalent equation with the variable terms on one side. That's what I said, right? Simplify, then get your x on one side. And look, it's not always x. In fact, it's never x, right? It's always, in this case, k or t or m, or they can't just stick with x because that's too simple. Okay. So here's our equation we're going to solve. 2 plus 5k equals 3k minus 6. And as we go, I'm going to write down fewer things. I'm always going to do the same steps. But sometimes you can do things in your head. It becomes a battle of which is more likely to mess you up. Copying something down wrong or doing something in your head. For me, I'm fairly likely to copy something down wrong. Okay? And I've had most of you guys in class, and some of you are too. But on the other hand, if I try to do too much in my head, I'm going to mess it up that way as well. So it's a balancing act. Write down what you need to write down, do in your head what you're able to do in your head without messing it up. So I start with the equation. Start with the equation. There's no simplifying to do on the left side. There's no simplifying to do on the right side. What I want then is I want to get the terms with k on just one side of the equation. I'm going to subtract 3k from both sides. This is an example of the kind of thing where I'm not going to write that down all year long, that I'm subtracting 3k from both sides. On the left side, 5k minus 3k is 2k. Now, 2 and 2k are unlike terms. Don't mess up and try to combine unlike terms. So I copy down the 2, and then 5k minus 3k is 2k. On the other side of the equals, 3k minus 3k is 0. Bring down the negative 6. What I have written in red, if you need to just do that in your head, do that in your head. What I want to do next then is get the variable term by itself. In other words, I need to get the constants on the other side. Remember what the step said? To get all the terms that contain a variable on one side and all the constants on the other. I've got the variable. There's only one variable term left. It's on the left side. Get all the constants on the right side. So I need to get rid of this too. I do that by subtracting 2. Why does subtracting 2 work? Because 2 minus 2 is 0, and the 2 is not there anymore. But I can't just subtract 2 from one side. You guys know that. I have to subtract 2 from both sides. On the left side now, 2 minus 2 is 0, but bring down the 2k. On the right side, negative 6 minus 2 is negative 8. I've got the variable term on one side, the constants on the other. At this point, it's almost always division. It could be multiplication, like if that was a 1/3 k, the way to get rid of the 1/3 would be to multiply it by 3. But it's a 2k, so divide both sides by 2. 2k divided by 2 leaves you with just a k. That's what we've been after the whole time. Negative 8 divided by 2 is negative 4. And at this point, let me remind you of something that we tend to lose sight of when we work a bunch of equations. What have we discovered? What we've discovered is that if I take the original equation, where'd it go? And I replace k with negative 4. I will get a true statement. That's what a solution of an equation is. It's the number, in some cases numbers, right, when we get to quadratic equations, that when you substitute them in for the variable, make a true statement. Watch how this works out. Following your order of operations, 5 times negative 4 is negative 20. On the other side, following your order of operations, 3 times negative 4 is negative 12. Back to the left side, what's 2 minus 20? Negative 18. To the right side, what's negative 12 plus negative 6? Negative 18. Now, I don't expect you to check them like that every time. I mean, nobody does. You're doubling your work for each problem when you do that. That means you need to get good enough at it, you don't need to check them. Make sense? All right, but again, don't lose focus of what a solution is. It's the number, or in some cases numbers, that make the equation true when you substitute that number in for the variable. Let's do a couple more. Number 1a here. 3w plus 2 equals 7w. Now, the previous example, I worked it where the variable was on the left side. Does the variable have to be on the left side? No, it doesn't. Does it matter? Not in the least. All right? So on this one, what I think I'm going to do is I'm going to subtract 3w from both sides. There's no simplifying to do. Subtract 3w from both sides, and then very quickly, we've got the variable on one side, the constant on the other. Because there's just one constant. There's just that 2. When I subtract 3w, as you know, 3w minus 3w is 0. Bring down the 2. On the right side, 7w minus 3w is 4w. Well, then, get the w by itself by dividing by 4. We divide both sides by 4. On the right side, 4 divided by 4 is 1, leaving us with a w. And on the left side, I could write 2 over 4, but what's better? 1/2, 0.5. I wouldn't count 2 over 4 wrong, because it's not wrong, it's just not simplified. Okay? So simplify your fractions, and decimals are fine as long as they're exact decimals. Try not to give me like the old 0.6666666 that when you finally stop writing it down, you're supposed to put a 7, or you do the 6 repeating. Try not to give me those. I'd rather have fractions than those. But terminating decimals, that's just fine. All right, do 1b by yourself. I'll uncover it step by step up here, but I want you to try to do the step first. You know how to do these problems. Oh, and by the way, is it possible to work it differently than me and still get the correct answer? Yes. So don't panic if yours looks different. We should end up in the same place. Have you ever gotten down to the end of a problem like this and you know that 4 divides into 12 3 times? So instead of putting 1/3, which is correct, you accidentally just put down 3 because you were just thinking of the division? Be careful. I know you know better, but that's a really easy mistake to make. 1/3. I'd much rather have 1/3 than 0.33333333. Any questions? All right, now this learning target was solve linear equation with multiple steps. Well, again, y'all have done all this kind of thing before. There can be a lot more steps than this. And you just got to make sure, be as careful as you can be without being ridiculous about it, right? You can't take 10 minutes on one equation. But be as careful as you can be without being silly. All right. Fractions. Everybody's favorite thing. I mean, it had to happen, right?
No.
It had to happen. That x over 2 bothers me a little bit. Does it bother you? It looks complicated. Not 2x. Where's the 2? The 2's in the denominator. X over 2 then is the same thing as 1/2 x. See how the 2's in the denominator? And when I rewrite it, it's still a 2 in the denominator. So do that first, because nobody really likes the x over 2. I mean, it's a little bit less to write, but it's harder to work with. So I changed the x over 2 to 1/2 x, and then I'm back in business. I want to get the x on one side, the numbers on the other. I'm going to subtract 1/4 x from both sides. You may not like it, but you know how to work with fractions. So to simplify 1/2 x minus 1/4 x, what I need to do is I need to figure out what 1/2 minus 1/4 is, right? To do that, I need a common denominator. 1/2 is the same thing as 2/4. So then 2/4 minus 1/4 is 1/4. So 1/2 x minus 1/4 x is 1/4 x. Bring down the plus 1. On the right side, 1/4 x minus 1/4 x is 0. Bring down the negative 6. And now let's get the x term all by itself. We only have one x term now. Let's get rid of that 1. The 1 is added. Do the opposite, so we subtract 1 from both sides. 1 minus 1 is 0. Bring down the 1/4 x. Be careful here. You're not going to get negative 5. Negative 6 minus 1 is not negative 5. It's negative 7. On the others, at this point, we divided. And we could technically divide by 1/4. But isn't it easier if we just multiply both sides by 4? Okay, so I'm multiplying the left side by 4. I'm multiplying the right side by 4. Now, I wouldn't normally write that on a separate line, but I wanted you to see what I was doing. What I would normally do is I would just do this from right there. Okay, and I do write that down. I almost always write that down. Well, 1/4 times 4 is 1, leaving me with the x that I wanted, and then negative 7 times 4 is negative 28. You started off different at the beginning, but you got the same, didn't you? And I'll tell you what else you can do for this one. This way that I just showed you is probably the shortest way, but I'm not sure it's the easiest way. If I take this same problem, we all kind of groaned when we saw the fractions, right? Let's eliminate the fraction. And you do that by multiplying. I can right off the bat multiply both sides by the least common denominator of the denominator. In other words, the smallest number that both denominators divide into. And the smallest number both denominators divide into is 4. Watch what happens when I multiply both sides by 4. On the left side, distribute that 4. 4 times 1/2 x would be 4 over 2x. And what's simpler than 4 over 2? 2x. And then 4 times 1 is 4. On the other side, 4 times 1/4 x. Well, 4 times 1/4 is 1 x. And then 4 times negative 6, negative 24. Now it's going to be easier. Now subtract x from both sides. 2x minus x is x. And now subtract 4 from both sides, and x equals negative 28. I don't care which method you use. I'm almost always going to do that second way. You need to be able to do it the first way, but let's face it, that second way is easier. All right, questions? All right, let's keep going. So this time, we need to use the distributive property to simplify, because remember, we're supposed to simplify each side before we start trying to shuffle things around. And you see a fraction again. Now, sometimes when I see that fraction, I want to do what I did on the second method of that previous problem, which is multiply both sides, in this case by 3, to get rid of it. But watch. If I distribute 1/3 times 24, I get 8, a whole number. And if I distribute 1/3 times 12, I get 4, a whole number. So the fraction, if I'm patient, the fraction goes away when I do the distributive property. Notice that, and you save yourself some work. All right, so here's my equation. On the left side, let's distribute the 6. And I went ahead and wrote that out. Do we still need to write out the distributive property? I'd rather not. Okay? If you need to write it out, if that's helpful, put that line in. If not, this line right here that I just highlighted, if you want to leave that out, I'm fine with that. I'm going to. Okay? So 6 times 5m is 30m. 6 times negative 3 is negative 18. 1/3 times 24m is 8m. 1/3 times 12 is 4. Finish from there. How we doing? And by the way, remember that problems aren't races. For some of you just go faster than others. That's neither good nor bad. The whole point is to get the correct answer at the end. Okay? Any questions? All right. Do 2A all by yourself. And notice I'm ignoring the part of the directions that say check your solution, because again, that just doubles the length of every problem. We've got to get good enough at it that we don't have to check them all the time. Check up here with me every so often. Make sure you're on the right track. Definitely check to see if you got the same answer I did. Remember the process. Simplify each side, so that meant distributed property on the right. Get your variable term on one side, constants on the other. That involves adding and subtracting. Then get the variable all by itself. So simplify, get the variable term by itself, get the variable by itself. Everybody get 2? All right. I think that's the only one on this screen we'll do. Now, sometimes we don't get x equals a number. Weird things happen. And we all hate it when this comes into play, because you never feel like, when I show you these two, when you work one like this on your own, you're going to feel like you must have made a mistake for this to happen. But you didn't. Now, as y'all know, I teach geometry almost all day long. This never happens in geometry because the equations we come up with geometry came from a geometric figure. It's going to get a number for the answer. But, you know, when you're not operating in necessarily the real world, you can get weird things. So here's what happens. Let's take a look at A. I'm going to work this, and I want you to work it with me the way I always would. I start off, I need to simplify each side. On the right side, I'm going to multiply, I'm going to distribute this 3 here. So I copy down the 5x plus 5, then distribute the 3. 3 times 5x, skip that line. Go down to here. 3 times 5x is 15x. 3 times negative 4 is negative 12. Copy down the negative 10x. You guys with me down here to the check mark? I've got like terms to combine again. All right. On the other problems, one step of simplifying was all we had to do. Now there's another step. On the right side, 15x minus 10x is 5x. So I need to do that. I need to simplify each side as much as possible before I start trying to maneuver the x around. So that one had another step of simplifying. Beware. At this point, I want the x's on one side. So I'm going to subtract 5x from both sides. But do you see that something weird's about to happen? On the left, 5x minus 5x is 0. All I have is 5. On the right, 5x minus 5x is 0. All I have left is negative 12. Now, you've been in school for a few years now. Does 5 equal negative 12? Of course not. That's just silly. Whenever your variable goes away, and you didn't do anything wrong, but there's no variable left in your statement. If your statement, if your equation is false, that means that there is no solution to this equation. There isn't a solution. So, since it was a false statement, no solution. No solution is what you put. And again, like I said, you're going to feel like you did something wrong, but you didn't. Not at all. Now watch what happens in this last example. That's right, last example that we're going to do. We do the same kind of thing. We're going to distribute this 3, and I'm just covering up the step where I wrote out the distributed property. Y'all said we didn't need to, and we don't. 3 times 2b is 6b. 3 times negative 1 is negative 3. Copy down the negative 7. Don't do anything on the right side. There's nothing that needs to be simplified with 6b minus 10. I'm not finished on the left side because I can combine the negative 3 and the negative 7 and get a negative 10. Look at what you just wrote down. Something weird's about to happen again. Because when I subtract 6b from both sides, I get negative 10 equals negative 10. Or even before I do that, it's the exact same thing on each side. It's all solutions. It's called an identity. That means all numbers are solutions. You can replace b with any number and you will get a true statement. So once you get the left side and the right side to be identical, the math term for that is identity. But what that means is every number is a solution. And I wrote all real numbers. That's the math thing to write. But if you write every number, I'll know what you mean. Okay? And then, believe it or not, we're going to have some worksheets.